off to P4. This is polynomials. And I'm going to go through this very quickly because most of you are somewhat comfortable with most of the polynomial ideas, except what really makes one. So let's start off with the definition. So what I'm going to define is a poly term. If you can define what a polynomial term is, then a polynomial is just the sum of a bunch of terms. That's all it is. Polynomials are the sum of polynomial terms. So a polynomial term is the product of a number and a variable that is raised to a whole number power. That's all a polynomial term is. Easiest way to think of it. It is a product between a number, also known as a coefficient, and a variable or variables. I mean, if you have 4xy, that's still considered a polynomial term. And the variable has to be raised to a whole number power. What's a whole number? What does it start with? 0, 1, 2, 3. It can't be fractions, and it can't be negative. And it definitely can't be irrational, pi, square root of 3, and all those weird things. How many of you have ever seen a polynomial with x raised to the square root of 2? What does that even mean? That even gets more confusing. So, when we're talking about a polynomial, it has to be part of this definition. So, my little questions. Is this a poly? A. 4x to the negative 2. Is this a polynomial? No. Why? Because it's raised to a negative power. So this is not a poly. Definitely not. It has to be a whole number power. All right? Is this a polynomial? Why? No, fraction, yeah, but what operation is fraction usually? See, the key word here is product. And this is not a product, this is a, what do we call it, division? Begins with a Q. Quotient. So this is a quotient rather than a product. Now I can make it a product. I can write this as 3 times x raised to the exponential laws. If you take a variable, you drag it through a fraction, what happens to the exponent?
It's squared.
No. What happens to an exponent if you bring it through a fraction bar?
It raises.
Raises it to what kind of power?
First.
It's already raised to the first. If I bring it up top. Oh! Exponential laws. A to the negative n is equal to
1 over a to the
1 over a to the positive n. So if you drag things through fraction bars, what happens to the exponent? Change it. Well, it's already positive. So if I bring it up, it becomes negative. So this is 3x to the negative 1. Right? Because if it was in the bottom and I yank it to the top, it becomes opposite side. All right. Now it's not a poly because the power is negative. So either way works. It's a quotient, therefore it's not a poly. Or the power is negative because when you bring it to the top and make it a product, it becomes a negative exponent. All right. What about negative 5x squared y cubed? Is that a polynomial? Yes. Negative 5 is a perfectly real number, perfectly fine real number. X is raised to a whole number, y is raised to a whole number. I don't care how many variables there are. I just care that those powers on the variables are whole numbers. Is a poly. So we need to have these type of things being polynomials. What about square root of x? Is square root of x a polynomial? Do you think it's raised to a whole number power? Square root of x? I don't think so. And I'll show you later why it's not. more definitively. Alright, so those are polynomials. We can add them and or subtract them. For instance, if you have 3x cubed minus 5x squared plus 2x minus the quantity 4x squared plus 7x minus 5. Okay. So those are our properties. Number one, what do I have to do to get these things to come together?
You switch the sign.
What property is that?
Distributive
property. What am I distributing?
The -1 to
The
everything else.
-1. So, if I put a 1 here, what property am I using by putting a 1 there?
Distributes.
Nope.
So what repeat?
If I can put a 1 here, why can I put a 1 there?
It's understood.
It's understood, but why? Because of the identity property of multiplication. So there's a 1 in front of this set of parentheses. By the way, there's also,
A 1 up there.
when you drop these parentheses, the property you're using is either identity or distributive. Either one works perfectly fine. So the first one becomes 3x cubed minus 5x squared plus 2x without the parentheses because you're distributing a positive 1. The second one changes sign because you're distributing
A negative.
a -1 to everything on the inside. So this becomes negative 4x squared minus 7x plus 5. And once you get rid of all the parentheses, now you can start combining like terms, which is what property? Combining like terms.
Associative.
Distributive.
I can't stand that
I
thing.
know it's horrible. So, combining like terms is distributive. To get the like terms next to each other, that's commutative when you're switching orders. So we're going to do commutative and then distributive. All right, so nothing goes together with 3x cubed, so he's all by himself. And then we got this 5x squared and 4x squared. Gives us a grand total of
-9.
-9x squared. And then this 2x and the -7x,
-5.
-5x. And then finally, plus 5. And that would be simplifying this polynomial expression. Yes, I'm going to pound these properties down your throat, and yes, you're going to at least know what the shortcut names are for them. So, distributive, commutative, distributive.
Do it again.
Distributive to get rid of the parentheses, commutative to get the like terms next to each other, distributive again to combine them.
Because commutative is regrouping, right?
Reordering. Grouping is parentheses. I usually don't even answer any of my questions with associative. Trust me on that one, because most of them I don't usually use associative. It's just saying you either add the first two first or the second two first. I don't do that a lot. I usually use commutative and distributive, and identity and inverse. Associative is, if you're going to guess something, don't guess associative.
What's the difference between identity and inverse?
Identity means you don't change it. Inverse means it's complete opposite. The only reason I would use identity and inverse is solving an equation. When you're simplifying, it's usually commutative and distributive. If that makes any sense. You won't get to identity and inverse. Well, I mean, identity is here by putting the 1. But inverse, it's usually with
It's a zero.
zeros or 1s. It gets you to them. All right, so that's adding and subtracting. It's not a big deal. Just remember to get rid of the parentheses first and then get things together. Don't try to get things together with parentheses around them. Multiplication. Woohoo. The better you know the properties, the less silly little mistakes that you'll make throughout the semester. Because you can always prove yourself right. All right, multiplication. We'll start off easy. -3x squared times 4x cubed plus 7x.
Distribute.
We're going to distribute. The monomial on the outside, I might as well give you some vocabulary. There's a monomial on the outside, and we're multiplying it by a binomial. All right. So we're going to distribute, and I'm going to do the mental step first. So we're going to distribute a -3x squared, and we're going to multiply it by 4x cubed. And then we're going to distribute a -3x squared, and we're going to multiply it by 7x. What goes here? A plus. If you're doing it mentally, it's the first one times the second one plus the first one times this. I'm sorry, the first one times the first one and the first one times the second. Okay, when I multiply these two together, the numbers I'm going to multiply first, what property allows me to do that? No, commutative, because all I'm going to do is switch the order. If you start thinking distributive, that'll make it a mess. So negative 3 times 4 is? Negative 12. X squared times x cubed is? But that has nothing to do with the distributive property. It looks like it, but it's not, because all you're doing is switching the order mentally. Over here, I would take care of the sign first. Positive times a negative times a positive? Negative. 3 times 7? 21. X squared times x? X to the third. But again, that's commutative property when I move those things next to each other. Can I do anything else? No, I'm stuck. All right, how about 2x minus 5, 3x plus 7. Making it hard? No. Making it clear. That's different.
Do you foil that?
I don't know what FOIL means. I know that, but I don't know what it means. So what I'm going to do is show you why FOIL works. Because most people learn FOIL, but they don't know why it works. Yeah. So the property we're going to use is the distributive property. Distributive property needs a single number on the outside and 2 numbers on the inside. So I'm going to create my single number by just leaving my group of 2x minus 5, and I'm going to distribute it over 3x plus 7. I mean, that's the distributive property. It's A times B plus C. So here's A, here's B, here's C. Let's see what happens. 2x minus 5 times 3x. Well, I could write that as this. What property allows me to switch their order? Commutative property. And then I can distribute 2x minus 5 times this 7. And I could change the order again. So it's a positive 7 times 2x minus 5. Distributive property. Eventually I'll get to FOIL and I'll show you where it comes from. And then I'm going to distribute 3x times this. 3x times 2x is 6x squared. And 3x times negative 5 is?
Negative 15x.
Negative 15x. And positive 7 times 2x is?
Positive 14x.
Positive 14x. And 7 times negative 5 is?
Minus 35.
Negative 35. All right, let's stop here for 2 seconds. Shortcut time. Where did the 6x squared come from? Well, it came from 3x times 2x. First. Where did the 15x come from? Well, 3x times the 5. That's here and here. That would be inner. It's out of order, but it's inner. And then here we have 7 times 2x. Well, here's the 7, and here's the 2x. That would be outer. So there's outer. And then finally the 7 times 5, that would be your last. So FOIL's here is just kind of buried inside of the distributive property. What happened is when people started noticing that distributive property was doing this pattern, it became a nice shortcut. But then people forgot where it came from, distributive property. Usually with distributive property, the 2 middle terms will combine. So we get 6x squared minus x, or 1x, minus 35. Perfectly fine FOIL. Now when I FOIL, I don't really FOIL anything. Seriously, I don't FOIL at all. I hate the idea of FOIL. The problem with FOIL is it only works on a binomial times a binomial. So I'd rather you think of it as distribution. Let me show you what I mean. And that way you never make a mistake with multiplying polynomials. If you just use straight distribution. For instance, x squared minus 5 times x plus 7. By the way, the 2 middle terms in this one are not going to combine. It's just weird enough. What I mean by distributive is you take this first term here and you distribute it over the second 2. So I'm going to go x squared times x is? X cubed. And then I'm going to distribute x squared to 7, and that gives me? 7x squared, and then I start with negative 5. Negative 5 times x?
Negative 5x.
Negative 5x. And negative 5 times positive 7?
7x squared.
Minus
Oh.
35. You get 7x
I don't
squared.
know, I was doing-
Oh, you're doing FOIL. Don't do FOIL. So I distribute the x squared over the first two terms, and I distribute the negative 5 over the first two terms, and it actually does become FOIL in opposite order. The reason I'd rather you do it that way is because of problems like this. A binomial times a triangle. There is no such thing as FOIL. There is no such thing as FOIL. You could do it two different ways. You could set it up as, two-digit number over a two-digit number and multiply that way, but I find that tedious. So my suggestion is you take the first term, multiply it, and distribute it. So 2x times x squared,
2x to the third.
2x to the third, 2x times 7x,
14.
positive 14x. Make sure you say positive or negative for each one of these terms, because it'll give you the sign. Yep, because it'll give you the sign for the thing. And then finally, 2x times a negative 4 is going to be a negative 8x. My next suggestion is if you multiply the second number across, this negative 3, when you do negative 3 times x squared, that gives you negative 3x squared. I highly suggest you line it up. Match it up with the x squared, because eventually you're going to combine like terms. What allows me to do this? Commutative property. I can move anything wherever I want it to as long as I have them all together. All right, negative 3 times positive 7x?
Negative 21.
Negative 21x. And negative 3 times negative 4
Positive 12.
is a positive 12. Oops, I was writing 15. 12. And then take these two and just add them together. So 2x cubed,
11x squared
positive 11x squared,
minus 29x
minus 29x, plus that's supposed to be a 12. It got messy. I started writing 15 for some reason. Don't ask.
Is that a plus or minus?
It's plus. It's plus. Negative times a negative. And there's your answer. How about this one? 2x plus 3 squared. 2x plus 3 squared. Write it twice. Write it twice. Do not write 4x squared plus 9 because that is definitely not the answer. You're trying to use a property of exponents that does not work because this has a a plus. Anytime you have a plus or a minus inside of a grouping symbol, don't simplify anything in there. Just leave it alone. So this becomes 2x plus 3 times 2x plus 3. And then you can either use FOIL or I highly suggest just distribute it and be done with it. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. All of it positive. 3 times 3, of course, is 9. So we get 4x squared.
Plus 12x.
Why do you add them together?
Because they are terms.
Property?
Us,
What property did I not say to use ever? Distributive property, because I can kick out the x. Plus 12x. One of these days. All semester long, I'm going to pick on you about this, so you might as well get used to it.
But this is something that should have been taught us way earlier.
They were, trust me, they were.
It was, but not.
Every math class I ever took, it started off with, here are the properties. Here are the properties. Then they ignore it.
Your head.
Yeah, then they ignore it and jump into shortcuts. I know. It's horrible. Life. How about this one? 4x minus 7 times 4x plus 7. I'll let you multiply those two together. Any which way you want. Distributive, FOIL, long multiplication. Yeah. Shouldn't take you that long. We still have to get back to radicals. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, 4x times 4x? 16x squared. 4x times positive 7? 28x. Negative 7 plus 4x, or times 4x?
Negative 28.
Negative 28x, and then negative 7 times positive 7 is?
Negative 49.
Which simplifies to
16x minus.
16x squared minus 49. What happens to the two middle terms?
They cancel.
Well, property is cancel.
Inverse identity.
Inverse identity. The inverse to give you 0, and then 0 plus anything is itself identity. Woohoo! Thank you. All right, and that's it. These have a special kind of name. These are called conjugates. And you better memorize this name and what it means. A conjugate is a binomial. It sometimes could be trinomial and higher, but binomials are the most common ones. And the only difference between them is one sign gets changed. Not both of them, because if you change both of them, that's an opposite or an inverse. So only one sign changes. Technically, it doesn't matter if it's the one between them or the one in front. It really doesn't matter. But most people change the one in between. So the conjugate of 4x minus 7 is 4x plus 7. The conjugate of x minus 5 is x plus 5. All you have to do is change one sign, and it becomes a conjugate. All right. So let's go back to radicals.